Okay, so I'll have kind of chain two talks. One of them is regarding the challenges, talking about hardware management. As I've already mentioned in the past talk, it's not trivial. Talking about a single type of piece of hardware that needs to be plugged into different systems and be used and be manageable according to the system in which it is being installed requires some additional capabilities for the device itself, both in terms of hardware and in terms of firmware. It's easy to have a given card plugged into a given system and make its PCIe operational. It's definitely not easy to make it manageable. So what we did is, when we started defining OCP NIC 3.0, we already looked from the first point in time into the hardware challenges, which are also addressing not only the connectivity, but also whatever it takes to allow managing that card and really having it self-configuring according to the system and doing whatever it needs to so that you can really use it in a automatic fashion, allowing you the kind of plug-and-play experience that you're looking for. So as you can see here, OCP NIC allows really NIC cards to be used in any given platform. It was already mentioned that you have signals called bifurcation. You have the present signals. You have also signals that indicate whatever the card can do to the system. The combination of all these really allows to use it in any kind of platform that you can envision where you have multiple PCIes. You can have what we are calling the single host, which is a legacy. That's trivial. You can have multi-socket server, but it's still a single host. And in many cases, you may want, for optimization reasons, to connect directly to each and every socket concurrently. Just to give you a sense why it's so important, when you have the QPI-UPI interface between sockets in a multi-socket server, you incur some latency, power penalty, and just name it. When you want to optimize that extra latency in your system to gain the extra performance, you may want to connect concurrently to those sockets. But at the same time, it's still a single host. It's still a single server running a single operating system. So it should not behave as multi-host card. And of course, multi-host servers, which now it's kind of, everyone talks about it, everyone wants to have those, and the availability of those is there already. So what does it mean to do self-adjusting configuration? Practically, the slot provides to the card information about the type of the system into which it is being installed. So a given card knows when it powers up exactly what's the type of system where it is being installed. It knows if it's a multi-socket, if it's a single host, multi-host, how many hosts, how many sockets. All that information is encoded into the card using few signals which are well described in the spec. Okay? Then the card provides its capabilities to the system. The card declares if it can have a single bus, if it is using 16 lanes, only 8 lanes, how many buses it may support, if it supports or not supports multi-socket server. All of that is also provided back to the system. The combination of that yields the operating mode. And the definition of OCP NIC was exactly to guarantee that the negotiation or agreement is well defined. So if you open the spec, it's exactly defined for each and every combination of those two declarations. The system declares what it is, the card declares what it can do, and the outcome is well defined. And finally, there were also descriptions here earlier regarding thermal requirements. It's not easy to guarantee thermal management of those cards. So it's also may be a possibility that those cards may require more power consumption that a given slot may provide. For that reason, a new operating mode was introduced in NIC 3.0, in which the system, before even powering up the card, can query certain information. That information provides the cooling requirements and the power consumption that is expected once you activate the card. So the system knows before it enables power to the card if it can tolerate it. So all the information is well defined within the spec. Now, management challenges. It's not only how to configure the hardware, but also the card needs to operate correctly within the system where it is installed. So a card that needs to behave as a single host card has certain programming model. It needs to expose certain management interface capabilities, certain resources, and just name it. While if it operates with multi-host platform, it needs to behave quite differently, because each and every host needs to see its own private card, being able to manage its own private card, and the system needs to be able to know when it configures a given resource to which host it's been configuring that. It's not so trivial. You may have a system with single BMC. You may have systems with multiple BMCs. So all of that needs to be addressed automatically by the card, exposing ability to manage a single host, multiple hosts, single operating system, multiple operating systems, concurrency. All that needs to automatically be configured in those cards so that you can guarantee that when you power up your system, you have exactly the configurability space that you want to have. When you manage NIC in multi-host system, then practically you have multiple PCIe buses. One connects to each and every host. Most likely you would like even to isolate between them so that one host cannot definitely access resources of the other host. And each one of them need to be able to boot independently. So it means that each one of them can be even powered off or on or perform its own reset at random relative to the others. And they may even run different operating systems. Not so trivial when you try to manage all that. Now, when you have multi-socket server, it's a new game. It's a different beast. It's a single operating system. You may have multiple PCIe buses, but still it behaves as one server. You need to expose only one entity in terms of resource, in terms of hardware, to that operating system. How to do that? That's the technology behind what we are calling Socket Direct. And to enable all these, definitely, into the card, there is a need for all these different configuration and monitoring signals that are embedded into the standard. Now, when you take multi-host capable OCP NIC cards that we have, like the one here, then practically those cards support all these operating modes. Just plug them to the right server, and they will auto-adjust the operating mode accordingly. They will even change the management model, the option one model. Everything is automatically reconfigured according to the system into which you plug those cards. And I'm happy to say that some of these is kind of proprietary because we have invested quite a bit of time to reach that capability. And at the end of the day, when you have such capable card, let's say that you need to have support in your data center for various types of servers. The benefit is that you just take one part number, stock it, and use it in each and every server that you need to. You don't need to buy different types of cards. You don't need to maintain different part numbers. All of them look alike, exactly the same, but with different capabilities, with all the mess that it can create. No need for. because you just take the same card, plug it into whatever system that you need, and it will operate correctly. So that's the good thing that was embedded into OCP NIC 3.0 by standardizing everything in terms of letting the card know exactly what the system is requesting it to do, and letting the card declare what it can do, and changing the card behavior automatically such that the whole game really can take place. So a few of these cards are illustrated here. On the left, you can see a by 8 card, and then you have 2 by 16 cards. We are also already working on large form factor cards, and all these are listed in OCP already. If you need to get some more information, you have, of course, the OCP spec at the top. You can get to our data sheets, or if you want to look for those directly in OCP portal, you have the link at the bottom as well.
Excuse me, did I understand you correctly when you said that you designed the standard in a way that your patents are have to be used in that standard?
No, definitely not. Okay. We do not restrict you to use our patented technology by any way. But if you are using our technology, we provide some more goodies for you.
Okay.
Okay? And sometimes those goodies are, we believe, justifying to use our product, hopefully.
I'm just wondering if a competitor were to also have the same functionality but did not use your trade name for Direct Connect, would that be an issue?
I don't quite get what you're asking.
You were talking about your Direct Connect technology from
Socket Direct, correct.
So some other vendors would probably have to do something similar to provide similar functionality.
Maybe.
Are you preventing them from doing that?
If they are doing that using their own technology, I have no say here. The spec allows to have multi-socket server, well-defined, well-operated. We are providing some extra goodies to really guarantee that you'll get the most of the juice from that server. If you don't use our technology, it will operate, but it will provide you some less performance.
So what I'm wondering is are you preventing a competitor from having similar management functionalities with your patents in OCP?
Sorry for intervening. I think we need to take it offline, and I don't feel.
Let's take it offline.
It's a little bit getting serious. I think we
well,
will.
I'm wondering, is OCP really open, or is it sort of open with some patents?
It's open with some rules, right? So I think definitely you are welcome to be more involved during this. We have a monthly call, and we have a routine engineering workshop. Join us, and you can sense the level of openness there. Yeah, thank you.
Nothing prevents you functionally from operating any card in any system.